we want to appreciate all the students and your hard work. We've been admiring and looking over your poster boards this morning, this afternoon. Great job, all of you. We want to recognize our winners, but before we recognize the winners, we had a couple of honorable mentions, and I want to recognize them. So when I call your name, will you please stand? We had, and I'm going to read your poster title and then give you the name of who done it or who did it. Excuse me, my English teacher would kill me for that. So one honorable mention was innovative, sustainable chip seals for climate resilient, high friction reflective pavements, enhancing safety and mitigating urban heat. Ms. Kalita Montazier, forgive me if I butchered that, but would you please stand if you're in here so we can recognize you? Kalita? Okay. Well, clap loud enough she can hear you. She's across the hall. All right.
She's in the demo room.
Okay. All right. And our other honorable mention was a case study on production variability of BMD and super paved mixes with RAP. Hafiz Mohammed Zahid Hassan. Good job. All right. So we have our winners. We have 3 winners, no particular order. We want to recognize them. And they were so good. I think we have a highlight reel of each one. Is that right, Michael? All right. So highlight reel number 1, full-scale field implementation of reduced temperature chemical warm mix asphalt in Oklahoma, Bebek Parwajuli.
Hello everyone. Today we are here to talk to you about our study, which is on the
All right. Picture. Okay, are you going to get in the pictures with us?
Hello everyone. Today we are here to talk to you about our study, which is on the full-scale implementation of reduced temperature warm mix asphalt in Oklahoma. As you all know, climate change has been causing a lot of disasters in our world today, and emissions from the construction sector has actually been found to be one of the main drivers of climate change. So in the asphalt pavement industry, the usage of reduced temperature warm mix asphalt has actually been found to be one of the ways where we can reduce our emissions. But the lack of well-documented demonstration of the use of WMA in real life has been one of the major challenges to WMA's adoption. And that is why in this study, we were aimed at demonstrating that WMA can actually be produced and paved at reduced production temperature. Also in this study, we wanted to compare HMA to WMA based on different metrics, based on fuel consumption, the rate of temperature loss, mix compactability, and stack emissions. During this field study, we produced more than 3,000 tons of HMA and WMA. And my colleague Bibek will give you more details about the data collection.
Okay, so during the field implementation of warm mix asphalt in short WMA, our main goal was to measure the temperature of asphalt mix at different stages of production. We use infrared sensors to measure temperature during production, loading, unloading, and throughout paving and compaction. As we can see from this graph, WMA production temperatures were consistently lower than the hot mix asphalt, in short HMA. Furthermore, this heat map shows the temperature across the width of the pavement, and we can notice that on WMA day, the pavement temperature was lower than on HMA day. The same pattern can be seen during compaction as well. Besides temperature measurements, we also collected weather data and monitored emissions like particulate matter and volatile compounds. We also collected asphalt mix and aggregate samples for lab testing. The preliminary analysis shows that the average temperature difference during production between HMA and WMA was about 50 degrees Fahrenheit. Also, temperature drops can be seen in both mixes at later stages. However, the rate of drop is faster in case of HMA. I would like to mention that previously we quantified the environmental impact of HMA and WMA in the lab, and the result shows that WMA has a lower environmental impact. In summary, I would like to say that the asphalt can be produced at lower temperature, which reduces the fuel consumption and eventually reduces the environmental impact. Moving forward, we will be analyzing fuel consumption and emissions data, and we will also be conducting a cradle-to-grave life cycle assessment. We want to give a special thanks to J. Lemon and Haskell Lemon construction team for allowing us to implement this warm mix design at the plant. We are also grateful to Ingenuity for providing the additives and pumps, Highway Data Systems for setting up the temperature instrumentation, and Montrose for recording environmental emissions. We are also thankful to ODOT and the Federal Highway Administration for sponsoring this project. Thank you very much.
All right. Can we get Vivek Parajuli to the stage? All right. All right, our second winner. Again, these are in no particular order. These are our winners. Okay. Reducing the carbon footprint of concrete mixtures in Oklahoma through industry academic partnerships. Ms. Gretchen Haymaker.
Hello, my name is Gretchen Haymaker. I'm an undergraduate civil engineering student at Oklahoma State University. Today, I'd like to discuss our research on reducing the carbon footprint of concrete mixtures in Oklahoma through industry academic partnership. Why are we doing this research? The Inflation Reduction Act and Federal Buy Clean Initiative aim for net zero emissions by 2050. So how do we achieve this? A life cycle assessment evaluates the inputs and outputs throughout a product's life cycle, assessing the potential environmental impacts. An environmental product declaration certifies a product's environmental impacts. Currently, no concrete mix in Oklahoma has a verified EPD. OSU has partnered with DeLisi to create preliminary EPDs for 40 batch mix plants that are approved for ODOT projects. Once we identify mixes meeting low embodied carbon requirements, DeLisi will obtain verified EPDs, allowing ODOT to show verified carbon reduction being considered during construction. The objective is to compare the global warming potential values of Oklahoma concrete mixes against the limits set by the U.S. General Service Administration. A literature review revealed that about 90% of global warming impact of concrete comes from upstream materials production, approximately 96% of that from Portland cement. We followed the NRMCA PCR for our LCAs, but we lacked access to upstream data. To validate our methods, we reproduced 3 of NRMCA's mix design LCAs, a 2,500 PSI mix with no fly ash, a 3,000 PSI mix with 40% fly ash, and a 4,000 PSI mix with 20% fly ash, achieving to within 3 kilograms of CO2 equivalents per cubic meter of the NRMCA mixes, as shown here. After validating our processes, we then produced 6 DeLisi mix EPDs, 2 for shoulders, 2 for main lines, and 2 for bridge decks. The first of each design was 100% Portland cement. The second contained fly ash. Each mix with fly ash showed a reduction in the global warming potential. As the industry moves towards net zero emissions, we must ask, how will we reduce the global warming potential of ready-mix concrete? Can we reduce Portland cement content by using more supplementary cementitious materials? Portland limestone cement has 10% lower global warming potential than traditional Portland cement. Can we reduce the cement content by optimizing the aggregate gradation? Research suggests this could reduce global warming potential by 15%. Can carbon sequestration during batching reduce Portland cement use? Preliminary studies indicate adding CO2 may increase density and strength while potentially lowering the overall environmental impact through carbon storage. As ODOT gears up for upcoming funding from FHWA's Low Carbon Transportation Materials Program, this research will help Delisi be prepared to meet the requirements for low carbon concrete mixes. Thank you.
Come on up, Gretchen. All right, for the record, she's one of mine. She's in my design squad at OSU. All right, and our last winner, recipient, evaluating the use of lignin-modified binder for sustainable asphalt pavements, Mr. Urbina Barrios.
In search for more sustainable materials in road construction, a collaborative research project involving Louisiana Tech University, Louisiana State University, and the University of Oklahoma are exploring a promising alternative to traditional asphalt binders. This project focuses on the potential of lignin, a natural byproduct sourced from rice husks, as a replacement for a portion of the asphalt binder. Currently, limited data is available on the use of lignin in asphalt binder and mix. The main objective of this project is to assess whether lignin can partially replace fossil fuel-based asphalt binder while maintaining the necessary performance standards. Specifically, this research examines how replacing 10% of the traditional binder with lignin affects the mechanical properties of asphalt mixes. This research employed hydrothermal carbonization to extract lignin from rice husks. Once produced, the lignin is blended with a standard asphalt binder in a ratio of 10% lignin to 90% traditional binder. Lab tests are conducted to evaluate the performance of this blend, including its ability to withstand traffic loads and environmental factors. The performance of the lignin-modified binder was evaluated using tests related to superpave and multiple stress creep recovery (MSCR) grading system. No significant change in the stiffness value of asphalt binder was observed with replacing 10% of lignin. The MSCR test showed promising results for the lignin-modified binder, outperforming traditional binders, which had lower or negative recovery values. This suggests improved resistance to deformation under stress. However, storage stability presents a challenge with the lignin binder, showing some phase separation over time. The asphalt mixes produced with lignin-modified binders exhibit a good resistance to rotting. However, results from their ideality tests on asphalt mix specimens are not fully conclusive at this stage. While early data suggests good performance in some areas, Further research is necessary to fully understand asphalt mix behavior, particularly in cracking. Despite some challenges, this study offers a promising stride towards sustainable asphalt production by using waste products like rice husks. Future work will focus on improving the lignin binder and addressing current limitations. Thank you.
Is Arbina in the room? I don't see him. But... Okay. Okay, I'll be happy to accept this on his behalf. No, we'll make sure he gets it. But let's have another round for all of our award winners. Great job. And so now I won't stand in the way any longer. I want to bring up to the podium. What? Yes, sir. Group photo? Okay, all the winners. Bring the cash. We need the money back. Gretchen and yeah. You want the honorable mentions as well, Dr. Zaman? Just yeah. Was there any honorable mentions in the room still? Yeah, please come up. Please come up. Okay. No, I don't.
All right, we've made it to the end. Thank you for sticking around. Round of applause for all of you for staying so long. I appreciate it. I look out into the crowd and see that a lot of my fellow ODOTers have left, so I'm taking down names. I don't see Dovey anymore. I don't see Matt, Tracy, so I'm gonna have to put their names down. But I really do appreciate it. Before we go, I know that we only have a little bit of people left, but I do ask that your name tags, if you will drop them off at the registration desk, we like to recycle them for next year with the plastic, doing what we can for the environment. So if you'll drop those off over there. Outside of that, again, thank you all for coming. I do want to give a shout out to the ODOT research team for putting this together. I do want to give a shout out to the ODOT video crew, to Russell for taking photos and helping, to the UCO crew. Again, this is our first year here for all of the stuff that they tended to as well, to OU and OSU as well as the SPTC, all the speakers, demo, and posters, to the students, thank you for sticking it out as well. We truly do appreciate it. Again, we will definitely see y'all next year. We appreciate, again, your commitment to research and to transportation all around. I'm going to go ahead and toss it over to Dr. Zaman. But again, thank you so much for attending, and we'll see you next year. Don't forget, students, PIs, ODOT champions, November 30th is the topic statement deadline for federal fiscal year 26.
Good afternoon to all of you. I think I have been, as Dawn started in her opening remarks, I have been involved with this Oklahoma Transportation Research Day for a long time. And I think we have kind of tried different options. So I think this seems like one of the things that we would be doing is sending you a kind of a brief survey that should not take more than 5 minutes. So I would really earnestly request you to take time to fill out that survey to give your feedback. So previously we have used a different venue, Cowboy National Hall of Fame. Now we moved into this one. What are the pluses? What are the minuses? This time I think we did for the first time a panel discussion on AI. What are the things? So this is basically a joint event in which two universities, Oklahoma State University and University of Oklahoma, join hand, and our center, Southern Plains Transportation Center, and ODOT actually all work together in order to bring something like this for you. So as Tara indicated, that we are really greatly thankful to all of you. So I just want to acknowledge the people who actually, the organizing committee, so let me go over these names. From Oklahoma DOT, we had Sherry Black, Ron Curve, Gary Hook, Becky Lyons, and Wayne Rice. From Oklahoma State University, we have Joshua Lee, who actually organized this poster session. So I hope, Joshua, I don't see you, but right there. So please, thank him. I want to actually really do this round of applause for you, Joshua. It is actually a lot of work that you believe or not, but Joshua is one of those people that would never give up and would always do the best he can. From University of Oklahoma, we have Olivia Daly, Michael Molina, Katie Whitman, and myself. And our graphic designer was Katie Hawkins. So this was really a pleasure to be able to work with all of these people in organizing this. So I'm particularly thankful to Dawn. She's extremely busy, but still she took time to be here. And she was here for a while, for the whole morning. Joni Seymour is also a very busy person, yet she stayed all the morning. And then Tara, she is also very busy, but she stayed with us for the whole day. Particularly, I think, this AI panel, I think we need to really thank all of the panel members, including our panel member who joined remotely, and Tab for actually moderating this. I think that this is something I would like to actually look, know your how you rate the survey. But I think this is good thing that maybe more of a lively way of having panel discussion. So as you provide your feedback, we want to know maybe next time what type of panel would you like to see, and challenge us, to bring the right people to have an event in next year. And we want to always do a better job. We want to also thank all of the presenters. We have, and I'm grateful to my colleague, Konstantin, for, traveling. He is a very busy individual, but you still took time to actually come here. We had, some of these, people from other, I do not see my colleague from University of Arkansas. So they really traveled a long distance to be, to be here. I'm thankful to all of our out-of-state guests. Most importantly, the students. The reason I'm a faculty is because we have students. They are our future. They are our leaders. So you have seen these posters, whether you won an award or not, but there were a lot of effort that actually went in preparing these posters. So this is a wonderful, wonderful event. If you did not win, I understand that everyone wants to win. However, to compete is also a good experience. Particularly, you saw these videos, they're 3-minute, so 3-minute videos. So we will encourage all of you to actually, all of our students, to whether we win or not, but please do participate. And I think we as faculty have really obligation to encourage them to participate. So I think that's a wonderful, wonderful opportunity. We had some of the poster presenters were from other states, so that we're really greatly thankful to all of them. Then the poster judges, those people also did a great job. So this time around, I think we, as you know, let me see, the poster judges should be, so Walt Peters, Wasim from Oklahoma Department of Transportation, Wasim Fazal from Federal Highway Administration, Dan Main from Dolisi Brothers Company, and Wai Shan from Oklahoma State University. They participated in the judging. So please give a round of applause for all of our students and the poster judges. Most importantly, any program, we need audience. And all of you are still here. So I think this is we greatly appreciate all of you. I'm pretty sure that you could have been at another place, but you chose to be here. That means a lot to us. So we're greatly thankful to all of you. We hope to see you again next year. And please take a few minutes to respond to that survey and tell us how we can do a better job. Anthony, you did a great job in conducting the poster sessions and also in what you do with our students, right? There are future leaders. You have so much energy. I hope I can borrow some of your energy. So thank you all, and you have a great afternoon and rest of the day. Thank you so much.